This tutorial is not meant as an introduction to Max or even Gen, but if you're struggling to learn codebox, then this could be a good way in for you. In a previous tutorial, we built a granular synthesizer with Max's MC objects, but in this tutorial, we're going to build a similar granular synth with a single instance of Gen. As you can see, there are really very few standard Max objects involved here, and if we go into the Gen patcher, you can see it's all built with code inside a codebox. And here's what it sounds like using one of my marimba samples. So let's get cracking. So on a fresh patcher, I'm just going to set up the standard objects required for this. So I'll start with a buffer object and I'll name that buffer sample. I'll need an easy DAC, a live.gain, and I'll send the outputs of this to the easy DAC. And finally, a gen tilde object. And for the time being, I'll just send the output of the gen to both inputs of the live.gain, like so. Okay, and now we're ready to start with the gen patcher. So I'll go into the gen patcher, I'll just maximize that and zoom in a bit. And I'll just create a comment which will list all the parameters that I want to be able to control. And I'll start with the density, and this can go from 0 to 100 Hertz, and this effectively controls the rate of playback of each of the grains. Then I want the grain size, and this is the total length of the envelope of each of the grains, and this can go from 2 milliseconds to 500 milliseconds. I want the grain pitch. This can go from -100 to +100 semitones. And we can have the position. This will go from 0 to 1, where 0 is the very beginning of the sample and 1 is the very end. Then we'll have spread, also going from 0 to 1. And when the spread's at 0, each of the grains will play back at the same pitch, and when it's at 1, we'll have lots of random variation in the pitches of the grains. Now, similarly with spray, which will go from 0 to 1, when the spray is at 0, each of the grains will start from the same position in the sample, and when it's at 1, the sample start will be all over the place. And finally, stereo spread. When that's at 0, playback will essentially be mono, and when it's at 1, there'll be all the grains will be spread out over the stereo field. Okay, so I'll move this comment over here, and I'll delete these two objects and just make that in line. And I'll create my codebox operator and connect those up. Make it nice and wide. Okay, so I'm now ready to start coding. I'll start by just setting up the buffer and the parameters. So I'll call this buffer the same as what we have in the main Max patcher. Just to avoid confusion, and we'll create these parameters. So we'll have param density, and the default will be, let's say, 20, and we'll have min 0 and max 100. Then we'll have param grain size. The default can be 100, and we can have min 2, max 500. And now I'm going to need to generate some triggers to start the playback of each grain. And I'll need to create these triggers at a rate corresponding to our density, using our old friend, the phaser. A trigger in Gen is really just any non-zero floating point number. But to make sure that we just get one trigger per cycle of the phaser, we'll need to capture the precise moment where the value of the phaser drops from 1 to 0. In other words, when the difference between successive samples is -1. And to monitor the difference between successive samples, I'll use the delta function. And hopefully there should only be one negative sample value per cycle. And in order to get zeros when the delta is not negative, I'll use the less than operator. So I'll declare my variable p, and that will be equal to the delta, or the difference of this phaser with a frequency of the density, and I'll say less than 0. And let's send that out of the gen patcher. So out1 equals p. I'll lock the patch and go back into my main patcher, and I'll just create a scope, hook it up to the gen, and I'll create an attr UI object for the density. I'll take the volume down and turn on the easy DAC, and you can see that we've got these clicks being generated. And if I take the density up, they get closer together, and if I go down, they get further apart. So now might be a good time to decide how many voices we want our granular synth to have. So let's say 30 for the time being, and we'll create a variable called voices and set that equal to 30. And so if I count these triggers, and there's no better object to count them than the counter operator, I can use the value of the count to trigger the grain voice corresponding to that value. In other words, grain voice number 25 will only be triggered when the value from my counter is also 25. Okay, so I'll create a counter. So I'll say C equals counter, and I'll send that P, and we can reset the counter with in1. And the counter will go up to the number of voices. Our trigger for grain voice 1 is not quite when our counter is 1, but when our counter becomes 1. So we need to use the delta operator again to capture the precise moment when that counter becomes equal to 1. So we can say trig1 equals the delta of that first boolean when that is equal to +1. And now we can use this trigger to start off a counter, and that's going to count 1 every sample, and we'll use trig1 to reset it, and this counter is just going to keep on counting. But when the counter has reached the grain size in samples, we want it to keep outputting that value. So let's first declare a variable up here called size. So size equals ms2samps size. So that's just the value of the grain size in samples rather than milliseconds. Okay, and so we want our count to output the minimum of the counter and our grain size. But we need to be careful here, because when our size is changed, we might start hearing clicks here in the end. So we'll need to use the latch, and we'll open the latch when we receive that trigger. That will prevent some clicks. Now the eventual output of grain 1 will be the product of the amplitude envelope and the value that we read from the buffer at the specified index. So I'm saying amp multiplied by the sample. Okay, so let's just declare these two variables, amp and samp. And for the amplitude envelope, we're going to use a Han window. Han windows are commonly used for granular synthesis because they create very smooth windows. And so I've declared this function up here, and we need to send it. The count and our grain size. Now, for this function to work the way we want it to, we've got to scale the count between 0 and 2 pi. So first we'll declare a variable called phase, and we'll say it's equal to the count divided by the size. So that scales it first between 0 and 1, and then we'll say phase times equals 2 pi. And the meat of this function is very simple. We'll just return 0.5 minus 0.5 times the cosine of our phase. And that's it. And now we can just return to this amp variable down here, and we can say han count 1, and we need the latch of that size, and the latch will be opened by trig 1. Now if we set this sample value to 1, and we can change the output to grain 1, we can just observe it in our scope in the main patcher. So let's go over there. So my size has an error. Okay, because I need to change that to grain size. So that error's disappeared. Now we have our beautifully smooth window. So if I change the density to 5, so it appears more often. Yeah, you can just about see that. Yeah, okay. Now let's work on our sample variable down here. So basically we just want to use a peak operator to read from our buffer. So our buffer name is sample, and we want it to read from let's say position plus count, count 1, and we'll set the bound mode equal to wrap, so we don't need to worry about using modulo operators, and we'll set an interpolation mode to cubic because that's my favorite. So we need to declare this variable pos, and pos is just going to be our position parameter scaled scaled between 0 and the total number of samples that the sample in our buffer has. So we'll say position times the dimensions of sample, like so. Okay, so now let's go back into our main patcher, and we can turn on the EasyDAC, and actually let's put a sample into our buffer. I'll use the drum loop, and we should be able, if we turn the volume up, we should be able to hear that sample. Yeah, and you can hear it's got that nice smooth envelope, so it's not like jarringly sudden or anything. Now I don't really like having this addition within the peak operator, so I'll just replace that with I for index, and I'll declare that up here. So I equals pos plus count 1. And now might be a good time to give our granular synth pitch functionality. And all we have to do to be able to change the pitch of our grains is just to read through the buffer more quickly. So we can just multiply this count 1 by our pitch, PCH. And let's go up here to declare that variable, PCH. and that's going to be 2 to the power of our pitch parameter divided by 12. So power 2 to the power of pitch over 12. So if we want original pitch, our pitch will be 0. 0 over 12 is 0, and 2 to the power of 0 is 1. So we'll just have count 1 times 1, so just normal. If we want to put it up an octave, we'll have our pitch will be 12, so 12 over 12 is 1. 2 to the power of 1 is 2, and so we'll read through the buffer twice as quickly. So let's just go into the main patch, and I'll create an attr UI object. I think I've got an error here somewhere. Oh, I need a semicolon here. Okay, and if I turn on the easy DAC and change the pitch and density, you should be able to hear that variation in the pitch. Okay, we're getting there, but currently we only have one functioning grain voice. And so rather than copying and pasting all this code, we're probably going to want to put this in a nice little neat function. So let's start creating this function, and let's just call it something really creative like make grain. And we'll need to know the voice number of the grain. And we'll need to know the output of this counter. So let's call that count. We'll need to feed it the buffer, our sample. So let's just call it buff. And we'll need to feed it the size, the grain size, the grain position, the pitch, the spread, the spray, and the stereo spread. Okay, so let's just, for the time being, just copy and paste this all across. And now we can start editing the names of these variables, so they make more sense to the function we have here. Okay, so we don't need the 1 after that trig variable declaration, and the C actually just refers to the count, and we need to check when that is equal to the voice number. Okay, and we don't need the 1 after the count either, and we'll just correct these. Size can stay as size. Position, actually I need to change this to position rather than pos. Now that's okay, and rather than SMPL, I'll change that to buff. This is all fine. I'll remove that _1, and this will just be pitch. Okay, I need to get rid of that. Get rid of that. This is buff, and I don't need the _1 after that, and there as well. Okay, so now I can call that function in the out1, just here. So I'll say make grain. So it's going to be voice number 1, and I'll feed it C, and I'll feed it the buffer name, which is SMPL. And then what have we got? We've got the size, position, we've got pitch, which is PCH here. We've got the spread, the spray, and the stereo spread. Okay, so now if I lock the patch, oh, no errors have appeared, so I'll go into the main patcher and turn on the easy DAC, and we're hearing the same thing that we did before we made that function. Okay, cool. Now we just need to be quite careful that we don't create any clicks in this function. We need to sort of wrap everything around a latch function. So this position and this pitch variable, and I think it's just those two, need to be within a latch. And we'll use the trig variable to open that latch. Just like that. Okay. Now let's work on the spray functionality. Now remember, spray randomizes the playback position of the grain. So within this latch function, we're just going to add some noise. Now, noise in gen returns a random floating point between -1 and 1. And the minus part of that is good because we want to go backwards as well as forwards with our random start times, and we'll just multiply this noise by our spray amount, and that's it. I could just tidy this up by putting that multiplication on a different line, so I can just say pos times equals dim buff. Okay, that's the spray done. Now let's work on the spread functionality. So the spread basically refers to the randomization of the pitches of the grains, and when the spread is 0, all the grains will be at the same pitch, and when it's at 1, the pitches will be randomly distributed between -12 and +12 semitones. Okay, I've just paused there and realised I hadn't been recording my cursor, so I apologise if that's been annoying. Anyway, so like we did with the spray, we're going to incorporate our spread functionality within this latch function, but it's a little more complicated than the spray. So I'll just multiply this by a variable called spread, and notice we're multiplying here, not it's not an addition like it is with the spray. And I'll just declare that spread variable up here. So spread is going to be equal to noise, and we'll scale that noise by our spread amount. And now we need to just say spread equals 2 to the power of spread. That's SPRD. And that's all done. Okay, sorry, my cursor should be being recorded now. So finally, we need to add stereo functionality and the stereo spread functionality to this make grain function. And to do that, I'll need to return 2 variables from this function. So we can just say it will return grain left and grain right. And I'll declare those variables up here. So grain left will be grain times pan left, and grain right will be grain multiplied by the pan right. And to get those pan left and pan right variables, I'll say pan left, comma, pan right equals pan, and I'll feed that function stereo spread and a trigger, because I'll need to use that trigger to open the latch, because I'll also be using some noise for this function, which we hadn't written yet. So I'll go above the make grain function and start writing this new function called pan. So we've got the spread and trigger as arguments. Okay, and let's declare a new variable called n, which will just be our noise, but let's latch the noise. So latch noise trig. And we need to scale the noise to go from -0.5 to +0.5. The central position, so the mono position will be 0.5. Far left will be 0, far right will be 1. So let's do n times equals 0.5. And then we need to multiply this by our stereo spread. So we can say n times equal spread. And then we just say n plus equals 0.5. And then, so for our left, we've just got the square root of 1 minus n. And our right is just the square root of n. And then we can just return the left and the right. And that's it for this pan function. Okay, so now we're ready to test this function with a single grain. So we can go down here, and because our makeGrain function is returning 2 values, we'll say out1, comma, out2. And that should mean that another outlet appears down here. Good, so we can create an out2 box down there. And if we now lock this and go into our main patcher, we've now got another outlet appearing from our gen patcher. So I'll move this patch cord across, and let's just turn the density all the way up and turn on the easy DAC. And you can see now that we've got all this stereo movement. And if I change the ATTR UI to stereo spread and turn this down to 0, it's just in mono. And if I go onto the spread, that also seems to be working. And the spray, yep, it appears to be working fine. And position, I'll need to turn the spray down. Yep, it's working. So now that our makeGrain function is working well, we just need to copy that over for all the voices. So I'll go back into the code, and when I'm thinking about sort of duplicating a bit of code, then I normally think about for loops. And so first I'd have to declare two new variables, out left and out right, and I've just set them to 0. And now we can start the for loop. So we can say for I equals 0, I is less than voices, I plus equals 1. And then we can say L, R equals, and I'll just copy this over. And replace the 1 with I, because I will represent the voice number. And then we can say out left plus equals L, and out right plus equals R. And then finally, down here, we just say out 1, comma, out 2 equals out left, comma, out right. Okay, that's it. And then if I lock that and go back into the main patcher and turn on the easy DAC, nothing happens. And I'm actually not really sure why this is, but believe me, I've tried to use a for loop for this, but whatever I do, it just doesn't seem to work. So we're just going to have to do this in a really annoying, like, copy and paste way. So I'll just copy that and delete the for loop. And we can leave out 1, out 2 as out left and out right, and we've got them declared up here. So we can start by saying L, comma, R equals makeGrain, and then we can change the I back to a 1. Actually, our first voice is going to be 0, because this counter starts from 0 and it goes up to 30. But actually we need to go voices minus 1. I know voices, that should be right. And then we finally have to say out left plus equals L and out right plus equals R. And now we just copy and paste 30 times. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And now we just have to change the voice number, which is the first argument of the function. So that's all done now. And if I lock this and go back into the main patcher and turn on the EasyDAC, we have something that sounds like a granular synthesizer. So let's just create all these ATA UIs. Now if I turn on the EasyDAC and play with the parameters, you should be able to see that we have a working granular synthesizer. Now let's change the sample. I'll use this harp riff. Cool, so everything seems to be working pretty well. And now it's up to you to find a nice UI for controlling all these parameters easily. I recommend using the nodes object. With nodes, you can control 2 or 3 parameters at a time because you've got X and Y movement, and if you hold down Alt or Option, you can increase the size of that bubble. It's up to you to work out how to get those values from the nodes object. Yeah, so this granular synth, you can add it to any patch, or if you're trying to build an instrument in a single instance of Gen, then you could just kind of tack it onto the end and include some granular functionality. Be warned that it is a little CPU intensive. If I turn on the EasyDAC and look at the audio status, you can see it is going a little bit wild. But yeah, you might find it useful anyway. So thanks very much for watching if you made it this far, and I hope you find it useful, and hopefully I'll see you again soon. Bye.